our FluidSIM software user interface. Last lecture we have seen what are the basic requirement of pneumatic system, and now we will try to build one. Okay, so first we will introduce what are the elements here, the symbols, and how to configure them in the software, and then we will build one pneumatic circuit, easy pneumatic circuit, so that we can understand how the working is. So सबसे पहले let's talk about compressor. This is the basic part. We have seen that there are only three basic parts: compressor, uh, secondary air treatment, then your control valve, and then the actuator, that is cylinders. Okay, so one by one we will take. So how to work in this system? We have clicked on new, so we got the new canvas. So now just our next task is to drag and drop the required elements. So I will show you one by one. So first one is compressor. Let's drag it over here. So now this is what? This is compressor. This is symbolic representation of compressor. We know that these symbols are required for building a pneumatic circuit. Now you can see here there are two compressor symbols. So basically in pneumatic circuits we are going to use this one. Okay. Now this only shows the compressor which is supplying air at certain pressure. Now how to configure this? This FluidSIM software is completely configurable depending on the user. So here, if I want to change or if I want to set the pressure of air, how I can do it? I will just double click on it, and you have observed one thing, that when I take my cursor on any of the element, it shows the variables, setting parameters. So you can see here operating pressure is set to 6 bar and maximum flow rate is 1000 liter per minute. So this is a standard set inside the software. Unless required, don't change that. Okay, so if we want to change, just double click on it. We get a configuration window. Here the pressure is set to 6 bar and this is the standard operating pressure for pneumatic, and we are not changing it, we are keeping it as it is. So this is compressor. Next major element that we talked about rather is secondary air treatment. Okay, so secondary air treatment, you can see here air service unit. This is nothing but your secondary air treatment. There are two symbols, this and this. This is more detailed, what you can say, more detailed representation, but this will do. We will be using this short circuit, so we don't want this. Okay, so here, what is this? This is FRL unit, wherein we will filter, we will regulate and lubricate. These three actions will be taken. Again, suppose this is compressor. Suppose I set my compressor to 10 bar pressure. Okay, means there is a setup wherein my compressor is giving me 10 bar pressure, and there is a requirement that my circuit should have what pressure? 6 bar. So how to do that? So once the compressor is supplying air at 10 bar, we are able to regulate that in our regulator. So how to do that? Just double click on it. See that air service unit, the nominal pressure is 6 bar. It is already mentioned. So depending on that, we have to change. If you are working at 5 bar, you can change it to 5 bar. No issue. Okay. So now what is the scenario? Working pressure is 10. Supply pressure is 10 bar and working pressure is 6 bar. Okay. Now next major element in our pneumatic system are valves. So you have to practice this. You have to practice this, draw this, then only you are going to remember. Because in software there is no need to remember, and you can just recall it by watching the symbol. But in exams there are no ring, so you have to practice this. And there are only four walls. I will tell you that, very simple. There are only four walls that you have to understand and remember. Okay. So basic four types that are used are here. See, in walls category, you can see here configurable direction walls, mechanically operated, pneumatically operated, solenoid operated, shut-off walls and flow control walls. These are the types: pressure control, proportional walls. Okay, so these are nothing but the types. Basically, what we are going to use are limited ones, and that are nothing but this configurable direction controls, because I will show you how to configure it according to the need of a user. Okay, so basically, first wall that is used is nothing but this is 3 by n wall. So what is this 3 by n? 3 by n means it's 3 by 2. Actually, this is 3 by 2 direction control wall. Now, why it is called as 3 by 2? As already told, 3 stands for port. That is how many port here? 1, 2, and 3. So 3 ports are there. That's why it is called as 3. Now, what about 2? 3 ports, 2 position. 2 stands for position. Position means what? The squares. So 3 ports, 2 squares, so 2 positions. So 3 by 2. Once again, I am repeating once again. Listen. 3 ports. Here you can see 3 by n. 3 by n. N means positions. Positions are configurable, so it is given as n. You can have number of positions. But standard we have only 2 positions in this 3 by 2. So 3 ports, 2 position means 2 squares. Okay. So this, which wall is this? This is 3 by 2 direction control wall. Now, depending on the working and everything, we will discuss. First, we will see what are the basic types. So this is 3 by 2. Now next, and let me tell you that 3 by 2 wall are generally used to operate single acting cylinder. That will also take here next. So first wall is 3 by 2. Next, mostly used 4 by 2. Now you can easily see that why it is called as 4 by 2. What 4 stands for? Ports. So you can see here that is 1, 2, 3, and 4. 4 ports are. Now how many squares you can see here? 2. So what is this wall is? This is 4 by 2. Okay, 4 by 2 direction control wall. Now just remember one thing, that why this is 1 and why this is 3, why this is 2. Why it is not like that 1, 2, 3, and 4. So there is a standard notifications for ISO that these ports are labeled, and how to label, that is the ISO codes for pneumatics. So in that, one is always stands for pressure. One is always stands for pressure port. That means whenever you have to supply this pressurized air, you will supply it to port number 1 always. Port number 3 will always be a return port. Port number 3 will always be a return port, and it is always extracted to the atmosphere, because as this is a pneumatic, we have air, so there is no harm in expelling it to the surrounding. So this is return port. So that's why 1, or you can say 1 and 3 are input ports. So 1 you will supply compressed air, 3 will be returned to the atmosphere. Now what about 2 and 4? So remember, output of direction control valve will always be 4 and 2. In 3 by 2 there is only one output, so there is 2. In 4 by 2 there are two outputs, therefore it is 2 and 4. Now what we will do of this ports? We will just connect it to the actuator and we will get the motion. Okay. So just remember, 1 for pressure, 3 for atmosphere, 2 and 4 for output. 2 and 4 for output. Okay. So now this is clear. I think it is clear that 3 by 2, this is 4 by 2. Then there is another configuration, that is, now tell me, what wall is this? 5 seconds. Yes, this is 5. That means you can see there are ports 1, 3, 5, 2, and 4. So there are 5 ports. And how many squares you can see here? 2 squares. So this is nothing but 5 by 2 direction control wall. Okay. So this is 3 by 2, this is 4 by 2, this is 5 by 2. Now there are another type that we are using are nothing but one more wall I will take. Generally it is with 4 and 5, not more than that. In paper also it will be mentioned that what wall you have to use, and you have to use that wall only. It will be written that use 5 by 2, use 5 by 3 wall to control the cylinder. Okay. So now one more, two more rather is remaining, that I will take one more. So this is what I have taken is nothing but a 4 by 2 wall. Now I will convert that wall into some other wall. Let's see how. So I have to configure this. So double click. Here I am converting this 4 by 2 wall to 4 by 3 wall. 4 by 3. Listen, 4 by 3. 4 remains same. Now what I have to change? I have to change third position. I have to add third position. Okay. So how I can do that? So this is nothing but a configuration window for the walls. If you double click on any element, rather you will be getting this configuration window. So don't change anything, just I will show you how to add one more position. Okay, so here you can see there is 1, 2, 3, and 4 position I can add, but I want to add only single position. Now this is first one, this is second, and this is third. So I will first add third position, which is same as the last. So I will search for it, and this is what identical. Yes, okay. Now I will change the middle position. Middle position will always be null position. Okay. This is cross, so this is straight, and this is null position. So your wall is now became what? 4 by 3, because see now ports are only 4, but you can see here that the squares are 3. So this is 4 by 3 direction control wall. Similarly, can we do it for 5 by 3? Yes. How? Let's see. This is, I have taken 5 by 2 wall, normal wall 5 by 2. Then what I will do, I will just double click on it. I will add this last position to the third box. So this is identical. This should be identical so that it should not be mismatched. So this is first, this is second, and in middle we will add null position. Okay, so okay, now you can see here, what you can see is this is 4 by 2, this is 4 by 3, this is 5 by 2, this is 5 by 3. Simple. 2 square 2 position, 3 square 3 position, middle position will always be null position, just remember. Also it is important that you label only in the default position. You always label in the default position. So this is always the default position, whatever it is labeled. So just practice these walls once or twice. You use it, it is very easy to understand, it is very easy to remember. Just remember that some basics, that the default position is only has to be labeled and not the other one. Okay, only one square will be labeled. See, everywhere only one square is labeled, not the other. So remember that. Now, so we have finished with compressor, service unit, walls. Now what else is remaining is nothing but your end action element, that is nothing but actuators. That is nothing but actuators. Now actuators are what? Actuators are actual moving elements, that is nothing but linear element or circular element. So that are called as linear actuators and rotary actuators. So in linear actuator we all know that there are piston cylinders. So there are pneumatic pistons and pneumatic cylinders. So in that I will show you that how many types we are going to use, how to configure, and that's all. Okay. So these walls are clear. Let's move to actuators. So in actuators, first one is, now from figure what you can say, this is what, this is single acting cylinder. This is single acting cylinder. Why it is called a single acting? Because there is only one port and it can get a supply from one end only, and then it is acting. So it is a single acting. Now how the return stroke will occur? As you can see, there is a spring. What will happen when the pressurized air comes from this end? It will extracted, move forward, and when this supply cuts off, the spring force will again push the piston back to its original position. So this can be called as single acting cylinder spring return. Single acting spring return cylinder. Okay. Now again, can we configure this? Yes, the question is yes. And how? Just double click on it, and single acting cylinder, here spring return it is given. So yes, spring return. Nothing has to change here actually. So most of the things are common, so nothing has to change. Just see that whether it is spring return, extension or retraction. Normally it is extension what we are using our kits. Now what is to be changed? Now we are doing this for this actuation, we are doing for sensing. Means in sequencing, once one activity is complete, then only we have to move to the other activity. So how we will going to know that one activity is complete? Means whether the cylinder is whether the piston is extracted or not. That how we will come to know. So we have to add certain you can say labels or sensors. Now if electronically we talk about, then it is sensors, otherwise it is mechanical also. So how to do that? So just see configuration. In parameters you can see here that maximum stroke means the stroke of this piston is nothing but 50 mm. It can be of a range of up to 5000 mm. Okay, so depending on the stroke length we can set it. So this is here, it is by default is set as 250. So this standard diameter are given, so accordingly area is given, so you can calculate the force. Now external load is not there, force profile is not required. So let's move to the sensing part. So actuating labels is what we are going to do. So suppose there is this cylinder name as A. So its label will be starting with A and its position will be either 0 or either 1. 0 stands for retracted and A0 stands for retracted and A1 stands for extracted. Okay, so let's see, let's give a label A0. So this label will be as A0. It will begin at 0 and it will end at 0. That means when you can give the range actually, but no need of to give the range, just give identical figures. So this should be, you can see that the maximum stroke is of 50, so it will be ranging from 0 to 50. So if it is extreme left, you can say that it is 0. So A0 is 0. And if it is extreme right, so you can say A1. Now A1 should be how much? 50. Both will be 50. So these are the labels set. So sensors are A0 and A1. This will be used to actuate certain next sequence. Okay, so this is how we configure. So you can see here your piston cylinder arrangement and the ruler comes. So this ruler will always be set to this point so that we can show the retracted position by A0 and extracted position by A1. This is how we configure the actuator. Understand? So this is single acting cylinder. Now Let's go to double acting cylinder. Here it is. Just drag it. So this is double acting cylinder, and in double acting cylinder you can see that what is the difference between single acting cylinder and double acting cylinder, that in single acting cylinder there is only one port and only one direction it can move in, and return will be by spring, so there is no need of another pressure signal. But here in double acting cylinder there are two ports. That means if air comes from this port, it will extract, it will stay there unless the air comes from. So if cutoff happens for to this port, this piston is not going to move back unless it is having certain external load. So if there is no external load, it will stay extracted position forever. Okay. So to get it back, what we have to do? We have to again supply the compressor from the other point. So from this side we have to push and then it will come back. So this is nothing but double acting cylinder. Okay. So now again configure. So double click on it. Again label. Now we have given A0 and A1 label to the cylinder A. So we cannot repeat that. So suppose this is cylinder A and this is cylinder B. We will start with B0 and B1. So now here configuration, nothing has to change. See here, you can see that one arrow is shown and one dark C is there in both the cylinders or actuators. So these are nothing but it is cushioning. Cushioning means to avoid the you can say stroking of this piston rod onto the walls. It is provided and it is kind of cushioning, air cushioning. Okay, it compresses the air and release it slowly through small orifice. So it is adjustable. Adjustable means you can adjust the pressure. Okay, so if you don't want, you can take out this adjustable sign. If you don't want cushioning itself, you can remove that. See here, but we will keep the cushioning. Okay, so we will keep cushioning here, both the sides. See here, these parts are cushioning on the front and on the back, both sides. So now sensing is on, so we have to give label. Now parameter once we will check. So now here the stroke length is 100. Here it was 50. Here it was 100. No issue. Depending on the standard piston cylinder arrangement, it is provided by the manufacturer, and you have to use the same one. Okay. So actuating labels again. Now what should be the label here? This is cylinder B. So this is B0. Okay. So beginning will be 0, end will be 0. Very good. Now here it is B1. So this point will be 100. End point will be also be 100. It is automatically set. So now the two sensing point B0 B1 A0 A1. So let's say okay, and again drag this ruler to the position of start and end. So you can see here this B0 is here and B1 is, when it is retracted B0 is sensing, and when it is extracted B1 will be sensed. Okay. Now